Alright guys, this is note card number 7, which is on the intermediate value theorem, and you see that it says number 1 of the big 5. What that's referring to is that there are 5 different theorems that we're going to talk about this year in AP Calc, and this is the first one. We'll call it IVT for short. So this note card is all about IVT. And the intermediate value theorem is, it says it's an existence theorem, which says that if a continuous function on an interval, cannot skip values. Basically, it's really easy to understand on a graph. If you start at some value A and you go to some value B, and that A value is the X value. So this Y value that corresponds with A is f of A, and the Y value that corresponds with this X value of B is f of B. So we basically have this function, and let's assume it's continuous, that goes from A to B. What IVT says is that that function has to pass through every Y value on its way from f of A to f of B. It's as simple as that. I'll say it one more time. The function has to pass through every Y value on its way from f of A to f of B. So let's pick some values so that this makes a little bit more sense. Let's say f of A is 1, and let's say f of B is 5. So I can pick any value between 1 and 5. Let's say we pick 4. 4 is right here. And so for some Y value, we picked 4, but you could pick something else. There has to be an X value that corresponds with that Y value on the function. So there has to be, if we picked the Y value of 4, what IVT says is there has to be some X value that corresponds with that point. So, and they're calling that C. Alright, so let's go through and read this definition on the note card. It says, the IVT states if 1, f is a continuous function on the closed interval from A to B. So our orange function here is a continuous function. Now, what this means is that this would not necessarily be true for a discontinuous function. If we had some function over here where we start at A and B, and we do something like this, where we jump up here, this would be a discontinuity, right? And so we have that definition of what continuity means, and from that definition of continuity, we can define this intermediate value theorem. That's why we're doing IVT after we talked about continuity. So the first condition in this IVT thing is f has to be a continuous function. Okay, so if it's a continuous function and it goes from A to B, and then it says and k is any Y value between f of A and f of B. So remember, in our example we used f of A was 1, f of B was 5, and we picked a k value of 4. Okay, we picked a k value of 4. And what it's saying is that that k value is between 1 and 5. Well, 4 is between 1 and 5 in our example. So if it's continuous, and if we pick a k value between f of A and f of B, then, and this is the third thing, there is at least one number C between A and B so that f of C equals k. In our example, k is, remember, 4. And so on this graph here you see that our point of intersection was right about here. So there was indeed a value of C that had a Y value of 4. Why do they say at least one? Well, you could imagine a function that maybe does something like this, goes up and down like that. And so for your y value of 4, there could be, 1, 2, 3 places, 3 values, 3 x values, where the value of the function is 4. Alright, so that's kind of the definition of IVT. Let's see what kinds of questions the AP is going to ask you about that. Typically you're going to see the words, does there exist or is there a time, when AP is asking you a question about this. Or at least I'll say often. Those are the words that you're going to see. Number 1, use the intermediate value theorem to show that f of x equals x cubed, that if f of x equals x cubed plus 2x minus 1, f of x has a 0 on the interval 0 to 1. So first of all, and as you're kind of working with this, it's going to help to visualize this a little bit. What is the value of the function? So what is the value of f at 0? Well, if we plug 0 in, none of those x's matter, and we just get negative 1. So on our graph over here, and maybe we can do something like this, we've got the point 0, negative 1. Okay, 0, negative 1. And if we evaluate the function at 1, so f of 1, that's going to be 1 plus 2 minus 1, which is 3 minus 1, which is 2. So we've also got the point 1 comma 2. 1 comma 2. And our function is going to travel, and I'm not sure exactly what it looks like, but it's going to travel up kind of like that, from 0, negative 1 to 1 comma 2. And you could graph that to get a better sense of what it actually looks like. It says, use the intermediate value theorem to show that f of x equals x cubed plus 2x minus 1 has a 0 on the interval from 0 to 1. Well, on our graph, it's really easy to say, well, there's obviously a 0 somewhere there. But this is kind of one of those airtight math definition types of things. So we want to go through our checklist and make sure that all of those things are true. And then we can say that there is a 0 on that interval. So the first thing that we have to say is f of x continuous? Yes, f of x is continuous. By the rules that we talked about in note card 6. It's continuous because all of its parts are continuous. There are no discontinuities on this function. So we can say f of x is continuous. And we don't have to prove that in this case. 2. Now we want to say k is a value between f of a and f of b. So we have to show that this 0 is between f of 0 and f of 1. Well, f of 0 was negative 1, and f of 1 was 2. So I can say, yes, there is a c value between, or there's a k value, so we could say 0 is less than f of 1, and it's greater than f of 0. So here's my second statement here. 0 is between f of 1 and f of 0. And if you want to put those values in, you can. Negative 1 is less than 0 is less than 2. And then our third statement is we can say, therefore, there's at least one number, c, so that f of c equals k. And it's asking us to show that. So we can say, therefore, I'm going to erase those numbers now. F of C, where C is between A and B, and maybe I'll put that restriction afterwards. F of C equals 0, where C is between A and B. Great. So basically what we had to do is we had to show that it was continuous. We had to say it was continuous. We had to show that 0 was between f of 0 and f of 1, which was our interval, remember? And then we could say that there was some value c where f of c was 0. And I know that seems like a lot of work for such a simple concept, but these are the things that AP is going to be looking for when they grade you. Alright, let's actually apply this to something real now. Number 2, and this was an actual AP question, because there are stars next to it. It says a car travels on a straight track. During the time interval from 0 to 60 seconds, the car's velocity measured in feet per second is a continuous function. Okay, that's probably important. The table below shows selected values of the function. So we're just answering part C of this free response question. It says for t between 0 and 60, there must there be a time when v of t equals -5. Justify your answer. So what we're going to look for here is, this is our interval from 0 to 60. We want to know what v of 0 is. Well, v of 0 is -20. We also want to know what v of 60 is. That's 10. Is -5 between -20 and 10? Yes, it is. So, must there be a time when the velocity was -5? The answer is yes. And then we can say because v of t is continuous, and that was given to us, remember it's a continuous function. And then we can also say, and -5 is between v of 60 and v of 0. And that's it. We're done. And really when you're justifying, I think if you just say it's continuous and that the y value is between the two y values, I think you're good. So that's the justification for this free response question. And you will be getting points from AP based on you even saying that it's continuous and using that as part of your justification. So this might be worth 3 points in AP. 1 for saying yes, 1 for saying that it's continuous, and 1 for saying that -5 is between v of 0 and v60. Alright, that is note card number 7.